Hello, beautiful people. We are going through the Module 10 pre-quiz. Your quiz is coming up, so we want to take a moment and review for the upcoming quiz. The first one that we're going to do is we're going to find the inverse of each function. Now, this one does have a few steps. There are multiple ways of doing this type of question. The easiest way that I know of how to solve for the inverse is by switching your x and y. So the first thing we're going to do is rewrite your f of x in terms of y. So we're just going to say y is equal to x cubed. After that, we're going to switch our x's and our y's. And then we're going to solve for our new y. So the first thing that we need to do here is we need to cube root both sides. These cancel out, or they undo each other. So therefore we have y is equal to the cube root of x. But remember, we don't actually have this y. This y represents our inverse function. So our inverse function is the cube root of x, so we must use the inverse notation. Very similar steps. I know it looks a little bit different, but very similar steps. So the first step is to rewrite it in terms of y. Second step is always to replace your x and y. In this case, we do not have an x, we have an n, but still works the exact same way. So I'm going to replace my n and my y. Now, this here is a term on its own, so it's grouped together. So we want to deal with the stuff that's outside of this bubble. So in this case, we need to subtract 1 from both sides. So I have n minus 1 is equal to 2y cubed. After that, take a deep breath. These two are grouped together by multiplication. You must undo the multiplication before you cube root anything. So here we need to divide by 2, both sides. 2 divided by 2 is just 1. So we are left over with y cubed is equal to n minus 1 divided by 2. We're going to continue up here. So we have n minus 1 divided by 2 is equal to y cubed. So we're going to cube root both sides. Again, these undo each other, or they cancel out. So then we have y is equal to the cube root of n minus 1 divided by 2. So then we have, again, we need to redo or undo this y notation into the inverse notation. So we have the inverse being cube root of n minus 1 divided by 2. Again, all of this is inside the root. State if the given functions are inverses. Here's the thing, though, we must use composition of functions. If it doesn't tell us the way we need to know if the functions are inverses, then we can use the same method above, pick one, and then solve for the other, or solve for the inverse. But because it says that we must use the composition of functions, this means we have to prove that f of g of x is equal to x, and that g of f of x is equal to x. If both of them are equal to x, or the identity, that means yes, they are inverses of each other. Okay, so all you have to do here is we're going to first plug in whatever g of n is inside our f of n. So we have f of g of n is equal to, so what I like to do is I like to start writing out the outside function. So f of n is the fifth root of n divided by 2. So in place of n, I'm going to write my g of n. So in place of n, I'm writing 2n to the fifth power divided by 2. So this here is my g of n. So immediately I'm doing a happy dance because I see that 2 divided by 2 is just 1. So I have the fifth root of n to the fifth power. And I have fifth root, n to the fifth power. These undo each other or they cancel. Therefore, we just have n or our identity. In this case, I wrote that we should get x because we were solving in terms of x. But in this question here, we're solving in terms of n, so we got n. Now, are we done? We are not done with this question yet. This is only halfway through. Now we have to solve for the g of f of n. And it's exactly the same thing, except now we're plugging in our f of n into our g of n. So I'm going to start writing out what my g of n is, and that is 2 times n to the fifth power, but in place of n to the fifth power, I'm going to be writing what my f of n is. In this case, it is fifth root of n divided by 2. And again, we're finishing off with what g of n is, and that is to the fifth power. So here again, I'm happy because I have fifth root to the fifth power. They undo each other or they cancel. So then we have 2 times n divided by 2. Again, 2 times and divided by 2, same thing, not same thing, excuse me, but they are opposites of each other, so they cancel. So then we have n left over. Both of them are equal to n at the end, so therefore, yes, they are inverses. We're going to do exactly the same thing on number 4. Now, here's the thing though, whenever you're using compositions or whenever you're identifying if two functions are inverses of each other, you kind of have to make sense. So for example, on number 3, I have fifth root and I have fifth power. Inverses are opposites of each other almost. So fifth root and to the fifth power are kind of opposites to each other. When I'm looking at number 4, I see to the fifth power and then I see to the third power. To me, that is cause for concern. I'm going to guess that they are not inverses, but you never know. So we're gonna double check. Remember, if one of these fails, you do not have to continue. You can automatically stop there and says, no, these are not in fact inverses. So let's double check this. So again, first thing first, I'm going to double check my f of g of n. I'm going to start by, it should be equals. I'm going to start by writing out what my f of x is. I'm going to erase this because it is in terms of x in this question, in this problem. So then I have f, excuse me, let's try this again. F of x is -2, but in place of x, I'm going to be writing what g of x is. In this case, it is 2x cubed minus 3. And then I have x to the fifth power. Okay, so this right here is going to be a very lengthy problem because we have 2x cubed minus 3, 5 times 2x cubed minus 3, 2x cubed minus 3, 2x cubed minus 3, and 2x cubed minus 3. And then we need to FOIL all of this out. So I'm going to save you some trouble here and say if I multiply all of this out and then I multiply it by -2, will all of it all of a sudden cancel out and give me an x? It does not. So I'm going to say not equal to x. So therefore not inverses. This 3 dot here means therefore, and they're not inverses, or you can just write no because it is asking to state if they are inverses. So no, they are not inverses. If you don't believe me that this does not end up canceling out, be my guest. FOIL, use the box method to double check the work. But again, easiest way is just to make sure that you have opposites in what you're dealing with. To the fifth power, to the third power, they're completely different, not opposites, so you do not have inverses. All right. Identify the domain and range of each, then sketch the graph. So we have 2 questions. So first off, we need to identify the domain and the range. Second, we need to sketch. Okay. So these here are square root problems. So we know that in a square root, there are restrictions of the domain. So what that means is there are values that x cannot be. If x is a particular value, then we get a negative inside, and we can't take a square root of a negative number because that will give us a whole set of headaches. So let's just start graphing here. There are different ways to graph. You may use transformations. You may use your reference points. What I'm going to recommend is always do the plug and chug method. You don't have to do it, but this is the method that I recommend. Start out with your endpoint, which is your h and k. So my h is 2, my k is -3. So here's 2, here's -3. That's going to be your endpoint. Now, look at your a value. If your a value is positive, then you know it's going to be an increasing function. If your a value is negative, then you know it's going to be a decreasing function with a reflection across the x-axis. So because a is positive, we don't care that it's odd. We just care that it's positive or negative. Because a is positive, we know it's going to be an increasing function, so it's going to go up. So then my x value needs to be increasing as well. So I'm going to be choosing my x values to be higher. So if I choose 3, will that give me a pretty number? So I want pretty numbers. I want to know what the square root of whatever is inside here. Oh, excuse me, that is my phone. I'm going to turn that off. I apologize if I made anyone go deaf over here. Okay, so plugging in 3. Plug and chug just like you were in beginning algebra. 3 minus 2 is 1. The square root of 1 is still 1. 1 times 3 is 3. And 3 minus 3 is 0. So when I plug in 3, I'm going to get 0. I'm going to double check that again. I'm plugging in 3 in for x. So 3 minus 2, excuse me, I'm turning off my phone. 3 minus 2 is 1. The square root of 1 is 1. 1 times 3 is 3. 3 minus 3 is 0. Okay, that verifies. Now, if I plug in 4 here, 4 minus 2 is 2. The square root of 2 is, I have no idea what that is, and I don't want to know. So I need to make sure that what I have underneath here, underneath my radical, is a pretty number. So pretty numbers are 1. I know that 4 is another pretty number. So off to the side, I'm going to say I want x minus 2 to equal to 4. I want the inside to equal to 4 because I know what the square root of 4 is. The square root of 4 is 2. And if I can take the square root of 4, then my life is happy. Okay, so in order to find out what x needs to be, I'm going to set what's inside equal to the number I want it to be. I'm going to add 2 to both sides. So I have x is equal to 4, 5, 6. So I know that my next number is going to be 6. 6 minus 2 is 4. Square root of 4 is 2. 2 times 3 is 6. 6 minus 3 is 3. Okay, so then we have 6 and we have 3. Now we're going to connect it. And 3 points are more than enough to sketch a graph of your function. Okay, we're going to do exactly the same thing on number 6. We're going to set up a table. Start with your h and k. Understand how it's going to look like before you begin. So we know this is a square root. So your options are going to be, maybe it's going to look like that. Maybe it's going to look like that. It might look like this. It might look like that. So those are all your options. But with a square root, you know that there's going to be an endpoint and there's going to be a restriction of the domain. Which reminds me, we did not actually state what the domain and range in here. So for the domain, there's different ways of writing this. The way that I like to write is Domain, always start out with the lowest or highest possible. Always start with your endpoint. So domain is all of the possible x values. So we cannot go lower than 2, but we can touch 2, so we have brackets. And then it's going to go all the way up to infinity for our domain. Infinity is a concept. We can't actually grab infinity, so you need to have parentheses here. For the range, again, what's the smallest it can be? What's the highest it can be? Well, the smallest it can be is, what is this, -3? And again, it can be -3. That is within our range. And the highest it can be, well, it goes on to infinity. So for this function here, our domain is 2 all the way to infinity, and our range is -3 all the way up to infinity. Okay, let's go back to number 6. We start with our h and k. So we have 1 and -4. And again, look at your a. If it's positive, you're going to go up. If it's negative, you're going to go down. So we are going up because this is a positive number. So I'm going to go up 1. So 2 minus 1 is 1. Square root of 1 is still 1. 1 times 4 is 4. 4 minus 4 is 0. And then again, I need to know that this is going to be one of our pretty numbers. So I'm going to, off to the side, set this equal to 4. Add 1 to both sides. Now you don't actually need to do this if you can do this in your head, but if it helps to do this off to the side, it works. So my next number is going to be 5. 5 minus 1 is 4. The square root of 4 is 2. 2 times 4 is 8. 8 minus 4 is 4. So I have my 3 points. I'm going to sketch that. So I have 1 and -4. I have 2 and 0. And I have 5 and 4. And then connect. And then here is our sketch. Again, it's asking for domain and range. So domain, what's the smallest x can be? What's the largest x can be? Well, the smallest x can be is a 1. And then it goes all the way up to infinity. And then the largest y can be is infinity, but the smallest y can be is -4. So we have -4 here. Okay, all right, just a few more here and then we're all set. Now we're moving on to the cube root. It's exactly the same, you guys don't even worry about it. Cube root, we know it's going to look either like this or like this, depending if it's an increasing or a decreasing function, if it has any reflections. Let me zoom in so you guys can see a little bit better. There you go. There you go. Okay, so same thing that we did before. We're going to start with our h and k. If I didn't mention this, I want to mention this now. Your h is always going to be the opposite of what you see here. So in this case, I see a +3, so it's going to be a -3. Our k is a +1. K is always going to be exactly what it is. H is the one that's opposite. Okay, because it is a cube root, we have to think of if there's any restrictions on the domain. Cube roots don't actually have any restrictions on the domain, so we will have to go one above and one below. So one above is -2. One below is -4. So -2, we're going to plug it in. -2 plus 3 is 1. Cube root of 1 is 1. 1 times -3 is -3. -3 plus 1 is -2. Do the same thing with -4. -4 plus 3 is -1. -1 cube root is still -1. -1 times -3 is 3. 3 plus 1 is 4. And I always like to draw these kind of off to the side so I have an idea of what it's going to look like. So I have -3 and 1. I have -2 and -2. And I have -4 and 4. All right. So immediately I want to draw a John Travolta. So in our class, John Travolta looks like something like that. But because it's not a cube root, excuse me, it's not an x to the third power, x cubed, it's actually a cube root. So we're doing kind of the opposite of that. So it's going to be like a horizontal John Travolta. So then we are decreasing, our A value is negative, so our left is going down. So we're looking like something like this. So from your turning point, you're going to go up, off to the side, and down, off to the side. Now we are not approximating our y-intercept. All I'm wanting is your 3 reference points here, just by plugging and chugging. If you wanted to find your y-intercept, all you have to do is you need to set your x equal to 0 and then continue from that point. All right, same thing for number 8. Identify your h and k. Again, h is always opposite, so I see a positive 2, that's going to be a negative 2. K remains the same. We're going to go up 1 and down 1. Negative 1 plus 2 is 1. 1 cube root is still 1. 1 times 2 is 2. 2 plus 1 is 3. Negative 3 plus 2 is negative 1. Cube root of negative 1 is still negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. I'm going to sketch that. So I have negative 2 and 1. Negative 1 and 3. Negative 3 and negative 1. Again, looking at our A value, it's going to be an increasing function. Again, for cube root, these are our options. Because it is increasing, choosing that one. And there you have it. Okay. Last one is not from Module 10, but I do want to review it once again. You guys are getting really good at these, but I do want to review some more. Okay. Step number 1 is I'm going to rewrite it. You don't have to rewrite it. I'm going to rewrite it because I like to draw arrows underneath mine to identify where my zeros or roots are going to be. Okay. So anytime you see an x value or a variable, you're going to draw an arrow underneath that, and then you're going to ask, what does this have to be in order for this to be 0? 0. What does this have to be? Excuse me, what does x have to be in order for this to be 0? Okay. What does x have to be in order for this to be 0? And then continue asking yourself that. After that, you're looking at the exponents. And the exponent tells you the behavior at that 0. So anytime you don't have an exponent, make sure you're filling in a 1 there. A 1 represents a line. A 3 represents a John Travolta. And if you had a 2, it would have been a parabola. So any evens will be parabolas, any odds will be John Travoltas, and 1 is just linear. Okay. You also need to know what your end behavior is. Now your end behavior is, let me back up. Your end behavior depends on your leading coefficient, if it's positive or negative, and also your total degree of their function. So in a factored form, what you're going to do is you're going to add up all of your exponents. So 3, 6, 9, 10, 11. So 11 is odd. So because we have odd, it's going to be the left-hand side and the right-hand side are going to be different. And then you have to look at your leading coefficient. What is this number out in front? Now this one doesn't really have a number out in front, but it truly does. If it's no number out in front, that means that number is 1. And because that number is 1 and it's positive, again, we don't really care what that number is as long as it's positive or negative. That tells us all we need to know. In this case, it is positive. So we know it is an increasing function. So for our right-hand side, we're going to go up, and our left-hand side is going to go down, okay? Because we want to be increasing from left to right. So then, once you have all of your information, you're ready to graph. So identify what your zeros are. You have a 0, 5, 4, -2, and 7. Your left-hand side is going to be going down. Your right-hand side is going to go up. And then again, you're looking at your, these are all John Travolta's. You're looking at your behaviors. So at -2, you're looking at a John Travolta. That's your squiggly. Then at 0, you're looking at a line. Now, a line doesn't mean you have to go a vertical line. It can be a diagonal line as long as it's still a line. Then at 4, you're looking at another John Travolta. At 5, you're looking at a line. And at 7, you're looking at a John Travolta. And it all should smoothly connect. There should be no sharp edges. And your behaviors should get you to your behavior, at 0 should get you to your end behavior, and it should all match up. Your end behavior is a certain way, and then you're drawing it, but it doesn't end up matching up towards the end. That something went wrong, so be careful. All right, guys, that was your review for Module 10. Your quiz is coming up, so if you have any questions, please let me know. If there are any mistakes on here, please let me know. I am human, so you know the drill already. Let me know if there's any mistakes. There probably will be mistakes, and that's okay. We can both learn from our mistakes. Again, if you have any questions, please let me know, and good luck on your quiz.